But our story begins with molecules in solids. You've probably noticed that everything in the universe fits into one of three categories. It's either a gas, like the delicious vapor just now floating up from your soup, or a liquid, like the soup itself, or a solid, like your soup spoon. These are the three states of matter: solid, liquid, and gas. And you probably also noticed that gases move about very easily. So do liquids. But what about solids? Do they move about easily? It certainly doesn't look as if they do, does it? Not of their own accord, anyway. But the funny thing about matter is that it never stops moving, even when it's in a so-called solid state. Strange as it may seem, even things that aren't moving are moving. It's just that you're too big to see what's going on. Now, if you could shrink and shrink and shrink, eventually you'd be small enough to go to the dance. Yes, the dance. Every supposedly solid and motionless object, including your soup spoon, is in fact teeming with billions and billions of little lumps of matter, all dancing about as fast as they can. Let's zero in on that couple over there and see exactly how it's done, in slow motion. Molly and Marvin attract each other. Come closer, and then suddenly change their minds, but not too close, and seem to push apart again, and to try to escape from one another. But they don't get too far before their mutual attraction pulls them together again, only for them to repulse each other once more, and so on, and so on. And all the little lumps are doing this to one another. They're all playing, now I want you, now I don't, alternately attracting and repelling each other. They never quite touch each other, but they never quite escape from one another either. And when you look at a whole lot of them doing it, you see that they make up a kind of lattice work. It's this lattice work pattern of little lumps that always stay more or less together that makes a solid a solid. That's what keeps solid things from falling apart. So next time you pick up a spoon or any other solid object, don't be deceived by its deadpan appearance. There's a lot more going on than meets the eye. Remember, the dance of the little lumps. Of course, if you want to be scientific about it, you won't actually use the phrase little lump. You'll take the Latin for lump, moles, and the Latin for little, cula, and you'll say moles cula, or molecule. The story so far. All solids consist of little lumps of matter which are continuously vibrating to and fro in a lattice-work pattern. It is this lattice-work of little lumps that keeps the solid from falling apart. The scientific word for little lump is molecule. And now, molecules in liquids. That chocolate rabbit that's sitting beside you, now that's a solid, isn't it? Because a solid is something that keeps its shape, right? And even though the molecules inside it are vibrating pretty fast, they do all keep together. Everything is orderly and under control, so the lattice-work pattern remains intact. And as long as you leave the rabbit alone, it will stay in the shape of a rabbit, won't it? Or will it? You forgot about the sun. The sun makes things hot, and when things get hot enough, they melt. They become liquid. They lose their shape. Liquids have no shape or form at all, except the form of whatever container you put them in. But if you leave a liquid alone, it will slop all over the place, as it's pulled down to Earth by the force of gravity. In fact, it's so keen to get as close to the Earth as it can that it will flatten itself out as it seeks the lowest possible level. But what happened to that nice, orderly arrangement of molecules that gave the rabbit its form? How could those well-behaved little molecules have allowed the solid chocolate rabbit to degenerate into this liquid chocolate splodge? Let's reverse the process and find out. The rabbit is sitting on the wall, all calm and collected and cool. if we could look at what's going on inside it, we'd see that its molecules are equally calm and collected, vibrating happily away in their latticework to a steady, even rhythm. Each pair of molecules being brought together by a mutual force of attraction, and then pushed apart by a mutual force of repulsion. Fine, until the heat of the sun gets to them. As the sun gets hotter, the molecules become more and more excited and go faster and faster, swinging to and fro more and more wildly. The hotter they get, the faster they go, until the inevitable happens. The force of attraction is no longer strong enough to hold them, and they burst apart as if snapping an invisible spring. Now it's a free-for-all. Molecules are barging into each other, right, left, and center, changing direction continually, slipping and sliding past each other, getting thoroughly mixed up. The speed of the heated-up molecules has caused them to slip out of their regular latticework, and everything has become a complete shambles. And so the rabbit falls apart. It loses its form and turns into a shapeless mess. In other words, it melts. That's what melting means. The breakdown of order. The collapse of the pattern of vibrating molecules that's been holding the solid together. So the solid becomes a liquid, because the molecules not only do a lot of bumping into each other, but they also do a lot of slipping and sliding past each other. And the more slipping and sliding they do, the more easily the liquid flows. So when it's hot, molecules speed up and solids turn into liquids. Just as when it gets cold, molecules slow down and liquids turn back into solids.
The states of matter are gas, liquid, and solid. Gases assume the shape and volume of their container. Particles of a gas are separated from each other, move in straight lines, and in a completely random manner. They change direction only when they collide with each other or the container. Liquids have a definite volume and assume the shape of their containers. The particles of a liquid are closely spaced, and so their motion is still random, but much more limited. The particles slip past and collide with near neighbors. Solids have a definite shape and volume. Particles of solids are in fixed positions and collide only with near neighbors.